We're on page 3 of the handout of the introduction to the trigonometric functions for an acute angle of a right triangle. And really everything on page 3 we've already done. I'm just going to move through it quickly to show you how we do this efficiently now that we've got the ideas. All right, let's compute the sine and the cosine functions at 30 degrees. The way to do that is to look at a special triangle that has that angle in it. So we're interested in the 30, 60, 90 right triangle. The side, if we make the hypotenuse 1, that's usually convenient. The side opposite the 30 degree angle has length 1/2, and the side adjacent to it has √3/2. Then the sine of 30 degrees is opposite over hypotenuse, 1/2, and the cosine of 30 degrees is adjacent over hypotenuse, √3/2, and we've solved that problem. Okay, the next one, compute the other 4 trig functions at 30 degrees. Well, we really have a couple of options here. The tangent of theta, if you remember, is the opposite length of the opposite side over the length of the adjacent side. So we could do that directly. We'd have opposite 1/2 divided by adjacent √3/2. And then, of course, the thing to do would be to multiply the top and the bottom by 2, or if you'd like, another option would be to invert and multiply. And then those 2's cancel out, and we have 1/√3. That works great. The other option would be to say, well, the tangent of theta, and I didn't really want a general theta. Theta here is 30 degrees. The tangent of 30 is the sine of 30 over the cosine of 30. That gives us 1/2 over √3/2, which is in fact what we were doing here. So that's another way of getting it. Okay, it turns out we're really pretty well done now, because the cotangent of 30 is 1 over the tangent of 30. And that's going to be 1 over the reciprocal of 1/√3 is just √3. The secant of 30 is 1 over the cosine, so it's 2 over √3. The reciprocal of √3/2, and the cosecant of 30 degrees is the reciprocal of the sine. So the reciprocal of 1/2 is 2. We've got that one done. Then repeat this for 45 degrees. Actually, no problem at all. We know that there is a special angle. It has a pair of 45-degree angles in it, and a right angle. And if we make the hypotenuse 1, then this is 1/√2, this is 1/√2, and now we can proceed to writing down the 6 trig functions for 45 degrees. Let's work with this one. Opposite over hypotenuse, 1/√2, or if you prefer, it's equal to √2/2. The cosine of 45 degrees, well, we know that it should be the same as the sine, really, because the co-angle of 45, complementary angle of 45 degrees is 45 degrees. But let's just check it. The cosine of 45 degrees is the adjacent over hypotenuse, 1/√2. Or if you prefer the form √2/2, that is certainly correct. Tangent of 45 degrees is opposite over adjacent. Well, that's 1/√2 divided by itself. And any non-zero number divided by itself is 1. The cotangent of 45 degrees is the reciprocal of the tangent. The reciprocal of 1 is 1. The secant of 45 degrees is the reciprocal of the cosine. The reciprocal of 1 over root 2 is root 2. And the cosecant of 45 degrees is the reciprocal of the sine. The sine, 45, is 1 over root 2. Reciprocal of that is root 2. So there you have it, the 6 trigonometric functions at 45 degrees. And once we understand how to do it, you can see that this actually tends to go pretty quickly.